Welcome, geometry students. Today we're going to learn how to show that a quadrilateral is a parallelogram. Before we work with today's target, it's very important that you understand all of the traits of a parallelogram. So what I want you to do now is go ahead and take a moment to pause the video, and I want you to write down all the traits that you can think of about a parallelogram. Feel free to look back in your 3.2a notes if you'd like, but I want you to tell me anything that you know about opposite sides, opposite angles, etc. Go ahead and take some time to do that and then press play. Okay, hopefully you've compiled a list that looks something similar to this. Go ahead and look over what I have, but you should know that in a parallelogram, the opposite sides are parallel. They're also congruent. So that's both pairs of opposite sides, congruent and parallel. Both pairs of opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect one another. If there is anything you left off of your list, please make sure you make a note of that because you need to know these facts very, very well. These are going to be the basis of what we're going to build all of the rest of the unit upon. So if you don't know one of these traits, that's going to really put you at a deficit. So please make a note of that and study that before you move on. So let's look at the different ways that we can actually show that a quadrilateral is a parallelogram. So keep in mind, if we need to show something or prove something to be true, we need concrete evidence. Sometimes that evidence is going to be an if-then theorem. Sometimes it's going to require us to show algebra to support our if-then statement, etc. So there's a lot of ways that we're going to be able to show something to be true. So let's start with one way. If both pairs of opposite sides, the key here is it says both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. In your annotations, what we're working with is we have our four-sided figure. Keep in mind we're looking at the converse. So the converse implies that we know it's a quadrilateral, but we don't yet know it's a parallelogram. That's what we're trying to show. So we have to give the evidence that this is indeed a parallelogram. So if we can somehow come up with the fact that the opposite sides are congruent, then that would be enough evidence to show it's a parallelogram. So anytime that occurs, we can prove that this is a parallelogram. So in your annotations, I'd like you to draw on your picture and then add the if-then statement. If you can show opposite sides are congruent, then the quadrilateral is a parallelogram. That's the first way you can show something is a parallelogram. Here's the second. So this is another converse because we're proving it's a parallelogram. If both pairs of opposite angles, so now key is both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in your annotations, again, you have that shape. So if you can show that both that pair of angles, that pair of opposite angles, and this pair of opposite angles are congruent, then your quadrilateral is a parallelogram. So that's two ways that we can show a quadrilateral as a parallelogram. Let's take a look at an example. Example 1 says to use the properties of parallelograms. This is a basketball hoop, and in the diagram we're told that AB and DC represent an adjustable support of a basketball hoop. Explain why AD is always parallel to BC. Well, if we look at this, what we know is that the length of AB is congruent to DC. Our goal is to show that those are also always going to be parallel, no matter how this is adjusted. Another thing that we know is the length of AD is equal to the length of BC because they're both 18 inches. So looking at this is not only a quadrilateral, but it's also a parallelogram because both pairs of opposite sides are congruent. So we're going to start with the fact that ABCD is a parallelogram because if both, the key there is both, you need to specify both, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So this is very similar to our paragraph proofs from last unit. So we're going to make a statement. Our claim is that this is a parallelogram, but the big part is we need to supply evidence using one of our if-then statements. And one of the two ways to show something's a parallelogram that we know so far is by showing that both pairs of opposite sides are congruent. So we've shown that this is a parallelogram. Now it's asking us to explain why segment AD will always be parallel to segment BC. Well, one of the traits that we listed before about parallelograms is that both pairs of opposite sides are parallel. So that would mean that both pairs of opposite sides, including AD and BC, will be parallel. So therefore, AD is always parallel to BC since the opposite sides of a parallelogram are always congruent. Are always parallel. They are also always congruent, but here that's not what we're trying to show. We knew that to get in the beginning. So what we're going to show now is that those are parallel. So we've made the conclusion that we wanted to. The key that you might be thinking is if this was to adjust, wouldn't that change the situation? Well, what's going to adjust if you move this basketball hoop up or down is simply the angles. The side lengths are still going to be staying constant. They're probably constructed of something such as metal, so they're not going to be able to change in length. But the angle at each vertex, that might change. But it's still going to remain a parallelogram because the opposite sides will still be congruent no matter what the angle measure might change to. So that's another piece to think about there. All right, another way to look at parallelograms and proving something's a parallelogram is to use the opposite sides. But in this case, we're not going to use both pairs of opposite sides. We're going to say one pair of opposite sides. So if we can show one pair of opposite sides to be congruent and parallel, then the quadrilateral is a parallelogram. Now, according to this, if we look at this, I'll let you put it in your annotations. If we look at this, what we're saying is if just one of these pairs of opposite sides is congruent and the same pair of opposite sides is also parallel, then the quadrilateral is a parallelogram. Now, that's enough evidence to show that this indeed is a parallelogram. So does that mean that the other pair of opposite sides is not congruent? Well, no, that's not what this is saying. It's just simply saying that you don't need to know that in order to confirm it's a parallelogram. Once we've established that this is indeed a parallelogram, now we know both pairs of opposite sides is congruent, both pairs of opposite sides are parallel, opposite angles are congruent, and so forth. So then it fills in all the rest of the traits. But minimum, if we can show one pair of opposite sides to be congruent and parallel, then that would be evidence to show that this is a parallelogram. So one thing you might want to be thinking of is what if we were asked to do this and we would need to use coordinate geometry. What that would mean is maybe I would need to find this distance and this distance using the distance formula. So that would be one way to confirm if those were equal in length. Another thing I might need to do is use the slope formula to show that they're parallel. So just some things to be thinking about of how we could show congruency or parallel in a coordinate geometry type of problem. All right, another fact that we could use to prove it's a parallelogram is the diagonals. So that one of the traits we know about parallelograms is that the diagonals bisect each other. So we can show that to be true if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So in your annotations, if you can show, there's your diagonals, if you can show that they cut one another in half, so essentially that would be a midpoint. If you can show that to be true, then the quadrilateral is a parallelogram. That is our fourth way of showing that a quadrilateral is a parallelogram. So please make sure anything that's boxed in the notes today that you study those methods, because those are going to be really, really important to us. Let's look at another example. Example 2 says that we are going to look at the lights of a the headlights of a car. So it says the headlights of a car have the shape shown at the right. Explain how you know that angle B is congruent to angle D. Well, at first glance, we know that this is a four-sided figure. So clearly it's a quadrilateral. But they tell us that the opposite sides, BC and AD, are congruent. They also tell us that they're parallel. And if we can show just one pair of opposite sides to be both congruent and parallel, then this is not just a quadrilateral, but a parallelogram. So let's state that. ABCD is a parallelogram. That's our claim. Now we need support. So because if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. So we have our claim, but then we've supported it. Your support today, when you give a reason for why it's a parallelogram, is one of the 4 boxes in your notes. So those are the 4 main if-then statements that you can use to show something's a parallelogram. If-then statements are really, really important, so please make sure you know those. Now, we've established that this is a parallelogram, but it didn't ask us to do that. It asked us to explain how you know that angle B is congruent to angle D. Well, if we look at angle B and angle D, they're opposite angles. One of the traits that we know about a parallelogram is that the opposite angles are congruent. So we can go on to show, therefore, angle B is congruent to angle D because, and now what we're going to do is we're going to state one of the traits of a parallelogram, because we know the opposite angles of a parallelogram are congruent. Now, the mistake people will make on this type of problem is they'll tell me the very last sentence. They'll state that angle B and angle D are congruent because they're opposite angles, and that makes them congruent. Well, the only time that those opposite angles will be congruent is when this is a parallelogram. So don't forget to do both steps. Number 1, you have to state that it's a parallelogram. And then number 2, you can use the trait of the parallelogram now that we've established it's indeed a parallelogram. So please make sure when you're doing your explanations that you do both of those parts. Okay, next one says, for what value of x is quadrilateral PQRS a parallelogram? What is the length of diagonal PR? Well, if we think about a parallelogram, we know that the diagonals bisect one another. So that means they cut each other in half. So if this is a parallelogram, point T is actually the midpoint of QS and PR. Those are both of the diagonals. So in order for this to be a parallelogram, 5x would equal 2x plus 9. Now this doesn't ask us to explain. Sorry about that. That should have been 5x equals 2x plus 9. So this doesn't ask us to write an explanation, it just says to find the value of x. So go ahead and pause your video and find x. Alright, we should have found that x is 3. If not, please look back. So what this means is, therefore, those 3 dots making a triangle just simply mean therefore. Therefore, when x equals 3, PQ RS is a parallelogram. That means that for any other value, If x were any other amount besides 3, this would not be a parallelogram because the diagonals would not bisect one another. Now we found x, then it says to find the length of diagonal PR. Well, if we know x is 3, then really that means PT is equal to 5 times 3, or 15. Now, if T is a midpoint, because it's bisecting that diagonal, then that means that TR is also 15 units. So therefore, we know PR is a total of 30 units. And we have found the information they needed. Last example. So this is an example of coordinate geometry. All it means is your shape, rather than just being a picture of itself, it's on a coordinate plane. So what we need to do is not just use the lengths or angle measures they give you, but use the actual points of the vertices of the quadrilateral to do calculations. So this is where we need algebraic support. So it's just to show the quadrilateral as a parallelogram. Well, we have many ways to do this. In fact, we have 4 methods. One we could do is to show that the diagonals bisect each other. If I go that route, then I'm going to use a midpoint formula. Okay, so don't write this yet. I would use the midpoint formula to confirm that the midpoint of BD is the same as the midpoint of AC. So I would need to do 2 calculations, and then I could prove that this is a parallelogram using the midpoint formula. So I would state that if the diagonals bisect one another, then it's a parallelogram. Well, them having the same midpoint would confirm that. So that's one way I could do this. Another method of proving a parallelogram is to show that both pairs of opposite sides are congruent. Again, don't write this. So if I want to show that these are congruent sides, I would use the distance formula. So I would need to confirm that the distance of AB is the same as the distance of DC, and I would also have to confirm that the distance of BC is the same as the distance of AD. So I would have to do 4 calculations there. So that's fine to do. That would confirm that this is indeed a parallelogram because both pairs of opposite sides are congruent. The last, well, I shouldn't say the last, another method I could use is to show that both pairs of opposite sides are parallel. Well, that would imply that they have the same slope. So I would need to calculate the slope of the opposite sides and show that they are the same. That's the method I'm going to use here, but you could use whatever method you'd like. Keep in mind slope is rise over run. So the slope of AD, I'm starting at A and running to D, so I'm falling 3 units and running 3 units. So that is a slope of -3 over 3. We know it's a negative slope because it's going down from left to right. So that would simplify to be -1 over 1. Now, if these opposite sides are indeed parallel, then the slope of the side opposite AD, in this case BC, would also have the same slope of -1 over 1 because we know parallel lines have the same slope. Well, if I look at this, I have a rise over run of -3 over 3, which becomes -1 over 1. So I have confirmed that AD is parallel to BC because their slopes are the same. Now I need to do the same thing for the other pair of opposite sides. So I need to find the slope of AB and I need to find the slope of DC. Go ahead and do that now. Pause your video. Okay, you should have found that both AB and DC have a slope of +2/5. Since they have the same slope, we can conclude that AB is parallel to DC. Now here, it doesn't ask us to explain our work, so we don't have to put this in a paragraph proof, but you do need algebraic support. So if you were to tell me, for example, that ABCD is a parallelogram because both pairs of opposite sides are parallel, I would say that you do not have your evidence. So the only way that you're going to be able to show me with proof, with concrete evidence, is by showing your algebra behind this. So So like I said, this is just one of 4 ways that I could show algebraic evidence that this is indeed a parallelogram. We could have used the distance formula, we could have used the midpoint formula, and so forth. So there's lots of ways to approach this. You just have to find the one that you're most comfortable with. All right, go ahead and try your You Try Nows, and let me know if you have questions the next time we meet. Thanks again, and have a good one.